This is my Arduino code for Lab 4, ENME351 Lab 4. It starts by declaring the time start and total time at 0 with the long function, so it has more data to read, or that it's allowed to read, and then doing the same thing for val ns, which was the value from the end scope, and val p, which is the value from the potentiometer, and then doing the same for the end time as well. In a loop, it starts the time with time start micros, and then it tells, it defines val ns to be an analog read from pin A1, and then val p to be analog read from pin A5. Goes into if loops, 4 different if loops. Val p is greater than 0 and val p is less than 250. The sampling frequency is going to be 100 hertz. For val p is greater than 250 and val p is less than 500, the sampling frequency will be 142 hertz. If val p is greater than 500 and val p is less than 750, the sampling frequency will be 200 hertz. If val p is greater than 750 and val p is less than the maximum bit 1023, the sampling frequency will be 500. And then I defined my dt in microseconds in one step, by putting 1000 over fs, or the sampling frequency, and then multiplying that by 1000 again. And then I told it to count how long it took to end the time, and then the total time is the time in minus time start, and then I delayed it dt minus the total time. These are my graphs for 75 hertz. The top left is 100 hertz, the top right is 142 hertz, the bottom left is 200 hertz, and the bottom right is 500 hertz. I'll zoom in on each. This is my 100 hertz. These are my 100 hertz graphs. The same order applies as the previous slide. This is my slide. These are my graphs for 215 hertz. Same order applies. These are my graphs for 300 hertz. Same order again applies. I created this spreadsheet for my calculations of the alias frequencies, both theoretical and experimental, for each given frequency of 75 hertz, 100 hertz, 215, and 300 hertz. For those frequencies that were aliased, I multiplied the Nyquist frequency by 1 minus the alias number minus the integer value. You can see the basic formula that I used up top. This is my square wave at 95% duty cycle and 10 hertz. The frequency domain graph seems to be having like a linearly decreasing value as the frequency continues, and the time domain seems to be extremely similar to that of the end scope output. This is my triangle wave at maximum amplitude that the end scope can put out, and 10 hertz.